when we are defining the ideal gases, right? We said that at the first postulate, right? We said that ideal gases are made out of gas molecules which are traveling in different speeds, right, towards different directions, but in different speeds. The straight line motions are with different speeds, right? So actually, with the Maxwell-Boltzmann distribution curves, we are actually discussing about those different speeds of molecules with the number of molecules or the fraction of molecules with those corresponding speeds, right? That is the major discussion here with the Maxwell-Boltzmann distribution, right? See, that is given there, right? They are saying that according to molecular kinetic theory, we know that the gas particles travels in different speeds. The speed distribution can be shown as a fraction of molecules traveling with particular speed as shown below. And this is called Maxwell-Boltzmann distribution of speeds, right? See, let's come up with the diagrams here. So it's kind of a graph where at the x-axis you have the speed of molecules, right? Molecular speeds in ms minus 1, and at the y-axis, right, you could have the number of molecules with this speed. You can have this y-axis like this, number of molecules with let's take this speed as u, with u speed, right? So we can draw Maxwell-Boltzmann distribution curve like this, or we can copy the Maxwell-Boltzmann distribution curve. Both are the same, looks like same, with some molecular speeds at the x-axis, and at the y-axis we can have the fraction of molecules with that speed. Fraction of molecules with u speed, right? Number of molecules means n number of molecules, right? Fraction means like the number of molecules divided by the total number. That is what we meant by the fraction, right? So you have a gaseous system with 5 molecules. See, 2 of them are traveling with 3 ms minus 1, right? So number of molecules with 3 ms minus 1 speed is actually 2. That is this, right? But fraction of molecules with 3 ms minus 1 is actually 2 out of 5. But that is the idea, right? Fraction means you have 2 molecules with 3 ms minus 1 speed out of 5 molecules. This is the total number of molecules. This is the number of molecules with that corresponding speed, right? That is the idea. So remember, this is always a constant, right? This is always a constant. For a gaseous system, this is a constant. 5 molecules, right? Okay, so see, this is how the two graphs can be considered with the Maxwell-Boltzmann distributions, right? And normally these graphs are like this. Following graphs, when a mirror shape at these graphs are with kind of a bell shape with some right tail. Bell shape with some right tail. Right tail means this is not symmetric, right? Here the area is bit more than the left hand side. So this is how it looks like. these curves look like. These are with some right tails, right? Alright, මේ වගේ සාමාන්‍ය මේ graph එක හැඩේ වෙන්නේ, right? Much more area to this side than this, right? So those are bell shaped with some right tail, right? Right. These are the Maxwell Boltzmann distribution curves for gas systems. Right. One with number of molecules as a y-axis, and one is with fraction of molecules with as a y-axis, right? හරි. දෙකම එක වගේ නේද? ලොකු වෙනසක් නැහැ. හරි පොඩි වෙනස් වෙනසක් තියෙන මේ අරින්න ලොකු වෙනසක් නැහැ. මොකද දෙකම shapes are the same, right? Okay. Let's discuss more about these things, right? First thing to say is actually this guy should start with y0. මේ curve එක අඳිද්දී වැදගත් දේවල් මේ කතා කරන්නේ curve එක අඳිද්දී හරි මෙහෙම පටන් ගත්තොත් වැරදි. Right? With speed 0, this is speed axis, with speed 0 you can't have any molecules. With speed 0 you can't have any molecules. Right? So should start with here, start from the origin. With speed 0, the number of molecules with that speed 0 should be 0. Now you know, right? As we are dealing with temperatures greater than Kelvin 0, you can't achieve the Kelvin 0. These are with some temperatures greater than Kelvin 0, 300 Kelvin or something. Then, right, kinetic energies are not going to be 0. Then the EK is with a value is not equal to 0, right? Because we know this is right. The kinetic energy is equal to this thing, no? Average kinetic energy, even, right? RTO, this thing. Yeah, this is per 1 mole, right? So basically, as this is not equal to 0, this is not going to be 0, right? So you definitely have a molecular speed for temperatures other than 0 Kelvin, because 0 Kelvin is not achieved, not such practical temperature. So always the molecules with 0 speeds should be 0, right? No? හරි එහෙනම් අනිවාර්යයෙන්ම මේක මෙහින් පටන් ගන්න බෑ. අනිවාර්යෙන් මේ වගේ ඔරිජින් එකෙන් පටන් ගන්න එක ඉතා වැදගත්. ඔයගොල්ලෝගේ MCQs වලේම correct graphs එක decide කරන්න කියද්දි then you have to choose the correct graph, Maxwell Boltzmann curve. You may have to consider this should start with 0, right? No? Hard. That is one thing. Then this Maxwell Boltzmann distribution curves represent some special speeds. Make special speeds keywords here. Let's label them. Here, this speed, actually these speeds gives us the right speed with maximum number of molecules. See, number of molecules with this speed is this much. That is the maximum value, right? Number of molecules with this speed is just this much, right? So actually this is the speed with maximum number of molecules, right? That is referred to as the right maximum probable speed. That is the maximum probable speed, right? Which is mentioned in denoted in as a CP. These are the symbols used. CP, peak velocity, right? That gives you the maximum probable speed. Right? The name is that maximum probable speed, the speed with maximum number of molecules. It's like this. The idea is this. See, you have 3 molecules with 3 ms minus 1, right? If you are to take a particle, if you are to take a gas molecule, right, randomly, if you are to take a gas molecule randomly from here, what would be the maximum probability for the speed it to have? It is 3 ms minus 1, right? Maximum probable speed, right? The speed with the maximum probability, right? If you take a particle randomly from a gaseous system, right? That is why that name is given to the speed with a higher number of molecules, highest number of molecules, right? Maximum probable speed, right? Here also you can see that appearing with the peak velocity or the maximum probable speed, right? So those should be you should know to mark those things, right? And then we have another two uh, type of speeds here. So speed type දෙකක් තියෙනවා මේක මාක් කරනවට පුළුවන් වෙන්න ඕනේ. එකක් තමයි c squared bar. අනිත් එක තමයි average speed. You should be able to come up with those two speeds as well, right? This is the maximum probable speed, c peak, and here you have the c squared bar, the square root, right? You can't have the c squared bar here. It should be the square root, right? C squared bar comes with m squared is minus 2, right? The square root only comes with the m is minus 1, right? So you have the c squared bar, the square root there, right? So here also that thing. And here at the center you have the average speed. That is how the three speeds locate in this Maxwell-Boltzmann curve. හරිනේ? right? තව පොඩ්ඩක් දේවල් තියෙනවා කතා කරමු, right? මේ ටික ඔක්කොම කතා කරලා ඉවරලා අපි මේක ඇඳගමු. right? Normally Maxwell-Boltzmann curves are drawn for a constant temperature, right? Temperature will decide the curve, the shape, and the shifts will be decided by the temperature. So normally those are drawn for a constant temperature, right? So these are some stuff. And another thing to mention here, this area under the curve, this area under the curve, this area under the curve, you should know what is representing by the area under the curve. This is the area. This is the area under the curve. This area. This is the area under the curve. In this one, this is the area under the curve. Right. So actually, in mathematics, right, when you are doing differentiation, right, Maxwell differentiation part. Maxwell right, ඒකේ මේ කතාව උගන්වනවා, right? right මේ ඔය කතාව ඔය area under the curve කියන්නේ මොකක්ද කියලා උගන්වනවා, right? ඇත්තටම the area under the curve will give you the summation of the y-axis. That is the idea. The differentiation lesson, the maths students will learn about that thing. Area under the curve, for any curve, the area under the curve will give you the summation of the y-axis, right? Summation of the y-axis. So what is the summation of the y-axis? This is the y-axis representing number of molecules. So its summation is going to be the total number of molecules. This is representing number of molecules with the corresponding speed. So earlier it was මතකයිනේ 3ක් කියලා ගත්තනේ. Number of molecules with 3 ms minus 1 is 3. The total is the area under the curve will represent the total. That means total is 5, right? Like that. That is the idea. So area under the curve represents the total of the y-axis. So here area under the curve is actually, right, total number of molecules, right? NT. That will give you the area under the curve for this thing. When it comes to other one, this one, The area under the curve, that is again an important one. Area under the curve will give you the summation of the y-axis. Summation of fractions. What is the value there? Summation of fractions? Summation of mole fractions. 1. Always the summation of fractions will give you 1 as the answer. So area under the curve representing unit 1 for this curve. Right? ළම උත්තර විතරයි මේ curves දෙක වෙනස් වෙන්නේ. The area under the curve, right? ඒකත් එක්ක තව පුංචි පුංචි දේවල් වෙනස් වෙනවා. හැබැයි ඒක නිසා මුලින්ම ළමයි ඕගොල්ලෝ curve එක කතා කරද්දී මුලින්ම බලන්න ඕනේ what is the y-axis. In going to the Boltzmann curves, you have to first consider what is the y-axis. You have to look at that, right? So y-axis representing two different ideas here. With that, the idea given by the area under the curve will differ, right? පොඩ්ඩක් මේක මේ practical usage එකෙන් පොඩ්ඩක් කතා කරමු. මෙන්න මේ වගේ දෙයක් තියෙනවා. So see. So if you think of a system with 5 molecules and system with 10 molecules, right? This graph would be the same with 300 Kelvin. System with 5 molecules, so system with 10 molecules, still the area under the curve will be 1. So the graph of fraction of molecules with u speed, right, with this one, right, for the system with 5 molecules as well as 10 molecules, you come up with the same graph if the temperature is constant, kept at 300 Kelvin, right? But here, for the 5 molecules, the graph would be like this. If you are talking about the 10 molecules, the area should be increased. So the graph would be something like this. A more area under the curve should be there when the more gas molecules are there, right? So that all depends on the y-axis you are dealing with. So always before answering a question on Boltzmann curves, right? First look at the y-axis, what it represents, right? That will decide the area under the curve, right? Main so first draw the two things, right? The two graphs. Then we'll discuss more about these things after that, right? Right, no? Right. Let's discuss how these things vary with the temperature as well as the molecular weight. It's like this, Namai. So basically, these molecular speeds, right? Speeds with molecules, right, will vary with the temperature and their weights, molecular weights. Like this, no? We all know that c squared bar, this thing, is equal to 3RT over M, the square root, right? This says actually the c squared bar, the square root is depending on the temperature and the molecular weight of the gas, right? So that means the T is high, c squared by the square root is high. When the M is high, this will be low, right? So basically those values, the values here will change according to the temperature and the molecular weight, right? Those depends. And scientists, they have found that the other two parameters, the C peak as well as C bar, they have found that these are also proportional to C squared bar. මේක හොයාගෙන තියෙන සයන්ටිස්ට්ලා අර ෆැක්ට් එක ඔයගොල්ලෝ දාලා තියෙන ඔයගොල්ලෝ නෝට් එකේ Cp is proportional is equal to 0.82 into c squared bar, that is proportional, as 0.82 is a constant, and this case Cp is proportional to yeah, that is so yeah, that is the only thing they have mentioned, right? Anyway, this one is also proportional, right? So means these values are also depending on the temperature and the molecular weight, right? So that when varying the temperature as well as molecular weight, means the kind of gas, when varying the temperature and as well as the kind of gas, the curves will shift, right, to right or left. Let's discuss about those things, right. Then our next discussion is about those, right. First, we'll discuss how the Maxwell-Boltzmann curves will vary according to temperature, right. After that, we can think of discuss on molecular weight acid, right. First, let's discuss how the Maxwell-Boltzmann curves vary with the temperature, right. See how these guys vary with the temperature. With two different temperatures. Let's consider the curves of the same N2 gas, right? Constant gas with two different temperatures. See, let's go for a fraction of molecules. Here, the speeds. I'm going to draw two graphs. See, මම මෙතන graphs දෙකක් අඳිනවා ළමයි. ඔයාලා මට decide කරලා කියන්න which one represents the higher temperature and which one represents the lower temperature. Tell me, right? I'm going to draw two graphs. ඕන graph දෙකක් අඳලා අඳිනවා. ඔයාලා මට කියන්න which curve represents the higher temperature and which curve represents the lower temperature. Right? ඕන curves දෙකක් අඳලා හරි මොකක් හරි විදිහකට හිතලා කියන්න. One curve representing 300 Kelvin, let's say the other curve representing 500 Kelvin, right? Tell me which curve represents the 500 Kelvin situation within two gas. හිතලා කියන්න. මම curves දෙකක් අඳලා දෙකේම area එක සමාන වෙන්න ඕනේ as we are dealing with the fraction of molecules, right? සමාන වෙන්න ඕනේ. Series සමානව පේනද මේ area එකට නිතර යනවා. So tell me which curve represents the 500 situation. You can use any kind of equation or anything. Just tell me which should be with the greater temperature, blue curve or the red curve. Blue curve කියන කට්ටිය. Blue, red. So anyway, let's discuss about this. Right? It is like this. I earlier said these things, the molecular speeds. I earlier said the molecular speeds are proportional to 3RT over m square root. Right? Earlier said no. This is equal. These are proportional. So one can say the molecular speeds are proportional to TOM, right? So as this is true, when the temperature is high, molecular speeds should be high. The values of molecular speeds should be high. When you are to think of the C peak, the higher C peak should be there with the higher speed. Higher C peak should be there with the higher speed, right? So which is the higher C peak? This one. This is the speed axis, right? You are not supposed to coming up with this, right? This number of molecules. But here you get the higher peak. So higher speed. So higher C peak comes with, right, greater temperature. So this should be the C peak for the 500 Kelvin, and this should be the C peak for the 300 Kelvin. With that, you can say, right, this graph, the blue colored graph, is with a higher temperature. Right? That is one way of coming up with the correct answer. Just applying this thing. Just applying this equation. This ratio. Or another method is there. This is actually how the max people think. Maximum equation maximum හිතන තමයි මේ කතා කරන්නේ. ඒව නැත්තම් දැන් බයෝලා මේක හිතන විදිහට පොඩක් කතා කරොත් ඒක පුළුවන්. බයෝලා සාමාන්‍ය කොහොමද දන්නේ? මේ විදිහට පුළුවන්. So it's like this now. See the idea here. If you have to think like a bio student, both approaches are okay, right? We know, right? We know that kinetic energy, the average values of the kinetic energies, will be given by this way, right? It is also equal to, it's also equal to 3O2 in RT, right? Okay. So as we are dealing with greater temperatures, as we are dealing with greater temperatures, right? We should be high. We should be high, right? So molecule speeds, right, go towards higher velocities, higher speeds when the temperature is high. Alright. Or temperature වැඩි කරද්දී kinetic energy වැඩි වෙන්න නිසා molecule speeds එක වැඩි වෙන්න ඕනේ. Because we are dealing with the same m, right? Each and every N2 gas particle is with the same weight, right? So increasement of kinetic energies should be because of the increasement of velocities, right? So the curves should shift towards greater speeds when the temperature is high. With this also, you can come up with the correct curve. ඉවත් මේ curve පේනවනේ. Curve එක shift වෙලා දිනවා greater speeds when the temperature is high, right? So that is the idea. So this is the higher temperature curve with higher temperature, and the red color one is the curve with lower temperature. Just write the when drawing the graph, just use these colors, right? That is the idea, right? When temperature increases, as the kinetic energy increases, the curve should shift to higher speeds, right? No? Okay, right. So this is what happens, right? When the temperature is high, right? හරි ඉතින් ළමයි ඔයාලා මේක අඳ ගන්න පුළුවන්. Put that thing also, right? දැන් පොඩ්ඩක් මේ කර්ව් එක මේ කොණෙන් අඳින්න ඕනේ. තව පුංචි පොයින්ට්ස් ටිකක් ලියන්න. මම මේ පොයින්ට්ස් ටික අතර ලියන්න. ඒකට පොඩ්ඩක් ඉඳ මැනේජ් කරගන්න. Right? When temperature increases, curve shifts to higher speeds, means molecules with lower speeds decrease, molecules with higher speeds increase. is also understood. When the temperature increases, curve shift to higher speeds. Curve higher speeds of the shift in only. Right? මේක නිකන් ළමයි අර මේ වගේ දෙයක්. ඔකට කොලුට ගත්තොත් මේ curve එක නිකන් ළමයි හරියට මේ වගේ දැන් you have to shift the curve keeping the area under the curve constant, right? Just look at this thing. You have to shift the curve to the higher velocities, keeping the area under the curve constant, right? The area under the curve always gives the number 1, right? This is fraction of molecular situation. එතකොට එහෙම මේ ගත්ත පස්සේ නිකන් අර මේ වගේ සීන් එකක්. නිකන් හිතන්න මේ just think of a thread එකක් තියෙනවා නූලක් වගේද? මේ මෙතනට මේ පින් කරලා තියෙන නූලක් ගැන හිතන්නේ thread කලර් එක. ඒ නූලම තමයි ඔයා මේට අදින්නේ. මෙතනට පින් වෙලා තියෙන්නේ. ඒ නූලම තමයි ඔයා මෙහාට අදින්නේ. You get the same area under the curve, right? So that is why the height should decrease. When you shifting the curve to the right, the height of the curve should decrease, right? එකත් වෙනවා. එහෙම තමයි වැඩි වෙලා තියෙන්නේ. මේක කියලා තියෙනවා මොකක්ද? When temperatures increase, curve shift to the higher speeds. When that happens, actually two things happens. When that happens, two things happens. What is that? See, number of molecules with lower speeds. With the red curve, you have, if you are to think of lower speeds like this, if you think of lower speeds, this is low speed situation. Means speed as is a low value. Kan? එතනදී බලන්න number of molecules with lower speeds ඉස්සර මෙච්චරක් හිටියා. red color එකේ. temperature වැඩි කරගම අඩු වෙලා නේද? Right? Number of molecules with lower speeds decrease with the temperature increase. What happens to the number of molecules with higher speeds? Higher speeds. High speed. What will happen? See? Early it was this much. Now that is this much. The value has increased. It's a metra ID number of molecules with higher speeds. Now you have this much. Okay? Number of molecules with higher speeds increase with the increasement of temperature. Right? ඒකත් විභාග ප්‍රශ්න අහලා තියෙනවා MCQ වල. So put this thing. When temperature increases, these two things can be seen. So Maxwell-Boltzmann distribution with different gases. Right. Let's consider the two situations. මේකත් අපි කතා කරමු අර වගේම gas දෙකකට. Let's discuss with two gases. Let's discuss with two gases, right? At constant temperature. Two gases. Correct? This you can use any of these things to come up with the answer. Correct? Tell me, think that these two curves represent two gases, the O2 gas and N2 gas, right? Tell me which curve represents the N2 gas. Which curve, or say, let's say this curve represents the O2 gas. Which curve represents the O2 gas? Neel paadagada, ratu paadagada, O2 gas represent kara. You can use any of these. Those are the main two things to use. Yes. Which represent O2. Neel paadagana kya cut blue color things for the O2. Red color thing for the O2. For the other, no? Right. So when the mass, the molecular weight is high, the molecular weight is high. When the molecular weight is high, right? Molecular speeds will be low. So the lower speed, lower speed, this is the speed axis. The lower speed should represent the gas with higher molecular weight. The gas with higher molecular weight. So this is the O2s, right? And that other thing represents the N2, right? No? Or else, if you are to think of this, right? How to come up with that? So we can say, right? As the temperature kept constant, this Ek is constant. This whole thing is a constant, right? Whole thing is a constant. So if you are dealing with greater weights, it is what happens with O2 molecules, right? To keep this value a constant, right? So speed should decrease parallel, right? As the temperature is constant, the kinetic energy is a constant, right? So this whole thing is a constant. With greater molecular weight, the particles are with more mass. The O2 particles are with more mass than the N2 particles, so that their velocity should decrease to keep this thing a constant, right? So that is what happens. So we can say when, right, when the molecular weight is high, the molecular weight is high, what happens? The curves shift to low speed regions. No? Curve shift to low speeds, means shift to left. Low speeds means to left, right? So in other words, we can say when those guys shift to left, right, number of molecules with lower speeds now going to be high. There is a red curve, no? The O2 number of molecules with lower speeds will increase. Number of molecules with lower speeds, right, will increase. Number of molecules with low speeds is a measure, right? With the O2, you have a high number of molecules with low speeds. Number of molecules with high speeds. Earlier, it was this. With high speeds, N2 molecules are this. But with the O2, that will decrease, right? This amount, right? Okay. So, number of molecules. Number of molecules or the fraction of molecules, both are same, right? Or molecules with, right, low speeds increase. Number of molecules with low speeds increase, and number of molecules with high speeds get decreased. Karan? කොහොමද අර weight එක වැඩි වෙනවා නම් ඒගොල්ලෝ speeds අඩු වෙනවනේ. That is the idea, no? When the particles are greater with weights, right? Their speed should be known. That is the idea. So just complete this one, right?